Perfect. Beautiful. Okay. I'm not getting on the floor. There's iPhone. So my name is Chad. I'm one of the tutors in math, computer science, and chem. So what we're showing on the screen is my actual MyShare folder, and my Canvas shell. I'm just pointing this out to you so that you know about it, and that you can see it. I'll show you that really quick, and then, not my email. That's not where it would be. For those that are on Zoom, this will be in the chat for you. It'll be a link. For those of you that are in person, there's the QR codes over here for you. Felt this was the easiest location for you to do that. Inside of them, there's notes, there's review, practice quizzes, and a whole bunch of other stuff that is accessible to you. And then all this recording plus the notes that I do up here. You guys can either take a picture before you leave, or I will put them in a PDF right there. Either or. You might have to stand up and do it. I'm not sure. That's totally up to you, but I don't know how close you're gonna get to it. That being said, so yeah, math section's right here. Depending on what, then you guys are 141. Depending if you're going to 142 or if you're going to do calculus next, or if not, I would do that. I would do 142. So don't straight into calculus. Don't do that. There's plenty of stuff there for you. And then we'll jump around where we need to go. Is there anything that we need to address at the beginning, or if you need questions from me before we get going? Yes.
Do you do 161?
161
for the functions?
I've only went up to 121, but there's some, I don't know if some stuff overlaps in it. There might be some stuff in there. I know there's 121 and 140 as well. So there might be some stuff in there. I'm not sure. Because I haven't taken it much yet. And on any others? Anything that we want to look at first? Any questions on anything that we might have? How do we feel about complete the square? How do we feel about like circles and those formulas? Okay, no. Give me a thumbs up or thumbs down, middle, like you get it, it's okay. This is the one that most people have problems with, partial fraction decomposition. No? Yes, okay. Okay. That's what I'm asking. Well, our spelling is wrong, but it'll be okay. What about factoring? I know that sometimes that's possible. It's been probably a while, but I made it this far, so that's good.
But what about completing the square?
Leave the square, huh? You can definitely look at that. That'll go hand in hand with this one. Any others really quick?
Oh.
Asymptotes of like a parabola or
Like, yeah, like finding asymptotes from
like end behaviors and all that.
equations. I'm not sure.
Okay. Okay, I'm gonna do both. Let's say zeros of polynomials. Probably sounds right. You guys can't read my handwriting, please tell me. I don't know write fast. Or that happens. Maybe. Okay, that's fine. Okay, so let's start off with thinking square circles. So there's a fraction. Think for one thing quick before I just pop it on my head. Or pull, grab, so I can grab one really quick. Sorry. Um, um, but it's right next to me. Definitely is. Alright, okay. I'm using the touchscreen as fast as I can, I promise. My head, but I don't know if it's gonna work. Yeah, forward. So if we have, so I'm gonna go circles first.
Yeah, transformation, so.
Yep. I typically do these in like with 2 hours, but felt this quarter that because last quarter I did them with 2 hours and they were just like they dragged. So I shrunk it a little bit, at least then people are sitting for 2 hours. So I get a little bit eat better, I guess. I think. Let's see how it goes. Okay, so for circles, we're gonna do this one. So it is x squared plus y squared minus 6x plus 4y minus, that's a minus 12 equaling 0. And then, so what would we do first with it?
We do the X's with the Y's, right?
Yes.
With the 12 on the other side.
Yes. So I'm gonna do that in all one step so that you are aware. Plus equaling positive 12 because we're moving that over. We're adding 12 to both sides, so move it over. So then with the complete the square, we take b over 2 and we square it. So we would take the 6, because no matter if it's negative or positive, we're still going to get a positive value out of it. So we're going to take the 6 over 2 and we're going to square it. And then what will we get out of that? 6 divided by 2, 3 plus squared is 9. And then we do the same thing for the 4, which is going to give us a 4 ultimately back. And something to note, when you guys are doing the complete the square, what you find on the inside of them is actually what your square is. So we got 9 out of this one, so we're going to get a 3 squared out of it. So that binomial squared that we get is going to be that. So of course we have to do it to both sides. Take these values and add it to both sides. So minus 6x plus 9 plus y squared plus 4y equaling plus 4 equaling 12. So then what would this first pair be? Mhm. And the second one?
X.
Yep. And then 12 plus 4 plus 9. I'm gonna do it on calculator because I'm not getting that one. 45. So then we fit the format of the circles that follow the x minus h squared plus y minus k squared is equaling to r squared. So if we wanted to find the center and the radius for this, what would be my center?
3 and -2.
Yep. I should have remembering the negative in it. Because if we look at this over here, we can look at this would be x minus 3 and then y minus a -2 is where we get this positive in the middle. And if we want the radius, we can square root the 25. R would equal 5. So our radius for this circle would be 5.
X minus H, that's the circle formula or something?
Yes, that is the general formula for a circle. Typically, they'll either give it to you in this format and they want you to complete the square and go all the way down to find it and then graph it. Or they'll give you something in this format and they want you to sometimes factor that out, but not really. And then you just have to graph it through this. Be good with graphing. X, Y, plot the points. So then partial fraction. We go to synthetic division and long division.
We do a long division.
Yep. No pun intended. That was right there. Sorry. So I'm gonna pick that one because it's not as long. I'm good to turn the page. Bless you. Yeah. So partial fraction composition. So no, I'm gonna need to choose for this. For a fact. So partial fraction. So for partial fraction, we have 4 cases. Most of them are pretty similar. Like case 1 and 2 are similar, and then case 2 or 3 and 4 are similar. So case 1 looks at the Okay, so case 1 looks at something that is in this format. So a over x minus a. And it looks at making sure that the bottom is linear. And Eric would just be a constant or a letter that we would consistently add. So A, B, C, and we just consistently go on with it with a plus. Whereas case 2 looks at the same thing, however, we have an n power with this x minus a. Where you get the multiplicities as well. Hopefully that rings a bell. And that's where that comes back. And then with yes, and then it repeats out. My bad. So it would go a x minus a n, and then it would go b x minus a up to that power. Sorry, I forgot to mention that. And then 3 looks at a similar thing, but it looks at the quadratic side of it, where we would have a x plus b over ax squared plus bx plus c. I'm gonna box these somehow so that you see what I'm talking about. And then case 4 is basically taking case 3 and then we're just going up to the nth power with that number. But that one would not be factorable. That's where that quadratic would not be factorable. You would put it in the quadratic formula and then you'd get some type of negative. That's where that would come, that's where that would pop, that's what that would show. Is what I'm trying to say. And something I'm going to mention really quick before we go into this. So if they give you a parabola, if you plug it into the quadratic formula and you get a negative on the outside of it, so negative b plus or minus square root b squared minus 4ac. So if you get a negative right here, with 141, it is not touching the graph at all. So if you look at just this equation and you get a negative with it, it's not touching the graph at all. It's going to be above it or it's just going to just curve above it. So it would be something way up here. So if you say, oh, find the x and y intercepts, and you plug in that into here with all the values and you get a negative out of it, there's a good chance it's not there. Just as a tip, so that you know. But so let's look at, let me put this one. So if we take x plus 9 and then we go x squared minus 9, am I looking at a quadratic or am I looking at something that can be factorable into a binomial? Or we have like something like this. Give you a hint, difference of squares. Since we have a minus in the middle.
Difference of square.
So we have follow this a squared minus b squared is equal to a plus b, a minus b. Not that part. Not bad. So if we were to factor this part, we would get x plus 9 over x plus 3, x minus 3. And then we can just use the cases to FOIL it out. Something to note that we don't want anything in the bottom to be 0 because we don't want 3 in the 0 in the bottom because it'll make it undefined. So our zeros would be x cannot equal 3 and negative 3. So which case would we be looking at in this first one? Sorry, what would be it? Case 1, 2, or 3?
2 or 1?
It's 1, because we don't have the power n over here. So with case 2 or case 1, excuse me, we would go equaling to a x plus 3 and then plus b for x minus 3. I'm writing that because there is another step that makes it super easy for you. So if we take the least common denominator, LCD, I'm hoping you've heard of it before, and we take it by both sides, we can eliminate the whole entire fractions. And so we can literally just plug and chug and plug numbers into these values so that we can get them by themselves. So we can get like a equals this, b equals this, and we're done with the equation. So if we multiply both sides by the x plus 3, x minus 3, does anyone need me to show you what is like the middle part of it? Yes, no, he's out.
Yeah.
Yes, okay. I'm just asking because what I was ask. So if we take this middle part and we take each of them multiplied into it, we're initially taking x plus 3. It's going to be over 1 regardless. X minus 3 multiplied by the x plus 9, x plus 3, x minus 3. Um, Times the whole thing. I'm not trying to make your hands hurt this morning, I promise. X minus 3. So the point of doing it this way with LCD of multiplying both sides is that it will take our denominators and cross them out since so like we have 1/1 equals 1, 2/2 equals 2. Well, in this case, we just have x plus 3 over x plus 3, which equals 1, so we can cancel it. Same situation over here. We have an x plus 3 in the top and an x minus 3 in the bottom. We can cancel it. Over here, since we only have the x plus 3 and x minus 3 in the bottom and on the top, that's the only one that cancels. And then on this, for this other one, only the x minus 3 cancels because that's the only one in the top and the bottom. You guys can kind of see the paint. I'll use a different color so that you can see it. So when we write it fully out, we're still taking the x plus 9. And then we also include the a times x minus 3. Yeah, you're good. You're fine. You don't have to ask. You're good. So the perks of finding the zeros is we can plug in the zeros to get these portions to 0 so that the a and the b would cancel. Is that okay? Okay. So if we let x equaling 3, 3 plus 9 equaling a times 3 minus 3 plus b 3 plus 3. We're going to get an a times 0. And then on this right side, we're going to get a 9 times b and a 12 over here. This part will cancel because it's just going to equal 0 at the end. That's much better. And so we're left with just 9b is equal to 12. What did I do wrong? Oh, that's 6. Not bad. Sorry. Please tell me next time. I'm not a mathematician, I promise. I'm not a mathematician. I make mistakes. We divide by 6. We'll get that b is equal to 2. Similarly, we can take a -3 into it, doing the same process. I'm gonna skip a step on this one. And this one will cancel because that'll equal 0. And then this other one, we're gonna get +6. That sounds right. And 8 times -6. If we divide by -6, we're gonna get that a will equal -1. So when we write it out, depending on how your instructor likes format or something of that nature, it may vary. But for this type of equation, x plus 9, x squared minus 9 is going to be equal -1 over x plus 3 plus 2 over x minus 3. Is that okay? Yeah. We need to see another one? No. I go to turn the page, give it a second. Yeah. Just the top. So with the parabolas, did we want to, in the asymptotes, did we want to look at one where we have to do the end behaviors for it? Or do we want to look at one that kind of looks like this and we're going in the process for it? Like using this, the factoring, finding the vertex, the vertice or the vertex, the axis symmetry, and the X and Y intercepts. Yeah.
The water. Back. Okay. It's like the one use like.
The vertices and everything. Let's look at. This one. So. I'm gonna go through the process, but I may not graph it for everything. Yeah. So parabolas. So for this one. So for this one, we're looking at a parabola, and we have the equation f of x is equal to negative x squared minus 6x minus 9 minus 8. Never mind. And so we want to find a couple things. So we want to tell whether it's up or down. We want the axis of symmetry and the vertices, or the vertex, sorry. Vertices is another one. We want the X and Y intercepts. And then I'm gonna say graph. So would we open up or down for this one?
Down.
Mm-hmm. Do we know why?
Because it's a negative constant.
Mm-hmm. That one is A, B, C. And then we want the axis of symmetry. And to find that, we would take negative B over 2A. We would take the opposite of it. So we would take the negative 6 over 2 times negative 1, which would give you a negative 3. I mean, I don't think that's a negative 3.
And an opposite of B.
Yeah. Yeah, okay, yeah, negative 3. There we go. I see it. Never mind.
I forgot what's the axis of symmetry.
Hmm?
What's the axis of symmetry?
So that's where the graph will lie. So for the axis of symmetry, so with us being at negative 3, it'll shift over 1, 2, 3, 4, 5. It'll shift right there on the graph. So that's where it moves over left and right. And then that the X and Y, the vertices tells you where you're at on that point. So if we had a -1 for the, we had a -1 as the x symmetry, that would be our bottom. That's the bottommost point of the graph, or your minimum, that's your minimum. Whereas if we were to flip it and we were up here, but we were opening down, this part would be my maximum.
That's the best.
Yes,
And some trees where like, in like, the center of it. like,
Yes.
the slopes.
yes. Because either side, if you only had one point on this side and it faced up, you could literally count how many spaces you are in the other direction and hit the point. Or a nice way to check your work too. For the vertex, we simply take the -3 in for the f of x. So -6 squared, double negative, -6, -3, -8.
Why is it -6 squared?
Oh, yeah, my bad. Thank you. Thank you for letting me know. So we should get, in a calculator, just gonna tell you what it is. We should get a +1. So if they want it as an ordered pair, most do, our point would be -3, 1. So on this line, we are actually right here. Are you guys good with me graphing it as I go? Or would you like me just to graph it at the end? Do either or it doesn't matter. And then for the x and y intercepts, so for y, it's pretty easy. Just plug in 0 for everywhere you see an x. So it's ultimately looking at this value. So you get -8. So f of 0 will equal -8. And the point for the ordered pair would be 0, -8. So down here weighs 1, 2, 3, 4, 5, 6, 7, 8. Would be down here. This is going to be a long graph, large graph. And then for the x and y intercept, for the x-intercepts, if you guys can't see it on there, please tell me. We would just take the equation that we're given and epsilon equal to 0. So -x squared minus 6x minus 8 equaling 0. And then we're just going to solve it. If we can't factor it, plug it into the quadratic formula, and we're done. And then we just do the plus and minus part of it, and we're good. So for just my personal habit, so my a is going to be -1, my b will be -6, and my c is going to be -8. And if we use the quadratic formula, -b plus or minus b squared minus 4ac, that's a square root all over 2a. Plug the values in, so we want the opposite of b, so we're going to go 6 plus or minus the square root of -6 squared minus 4 times -1 times -8 all over 2 times -1. And when you plug into a calculator, you should get 4. All over -2. And that will give us 6 plus or minus 2 over -2. So then we're going to take this and we're going to look at the positives and negatives of it. So we'll have 6 plus 2 over -2, 6 minus 2 over -2. I'll look at that one really quick because I know what I have written. So for one of them, we're gonna get a -4. And the other one, we're gonna get -2. So if they want the ordered pairs for the x-y intercepts, they would be -4, 0, and -2, 0. Yes,
Could we also done that by just factoring it?
yes,
Okay.
if it's factorable. Yes. So you could use like AC method, trial and error, not a method that I recommend, but it's doable. Quadratic formula, if there's patterns, so like the different, the complete, um, that one. See, that one. Or if they have another one where it's a difference of cubes or sum of cubes, you can use that one too. Either way, it can get to it.
So does doing the quadratic formula always work?
Mm-hmm.
Okay.
Mm-hmm. It usually works 9 times out of 10, which makes it super nice. And then we would get a -4, 1, 2, 3, 4, -2. And since we don't know this point down here, we can just count how many spaces we're away from it. So 1, 2, 3, 1, 2, 3, and we're going to be out here. And then we would just connect the graph. Even though my arrows don't look that great that inside. Is that good? Ringing some bells, I hope. I'm not doing the page, I'm skipping back to the other ones because I can know looking at things. Mm, Which one? This one?
Yeah.
So the first with axis symmetry, it's symmetric on both sides. So how I was talking about earlier, if we take how many spaces we're counting from, we just count the other direction and get the other point. So since we're at -3 as my axis of symmetry, 1, 2, 3 spaces, we can go the other direction and go 1, 2, 3 and get the point that we met that we're at. Because we know it's going to be at -8. And then we also know that if we count that many spaces to the left, we're going to hit that point. Oh, because we have the y-intercept right here.
Oh.
Very good. Whether you asked them or not. Very good. So you're good to turn the page. Yeah. So next. So I'm gonna do a longer one for the other one. No, that's right. So I'm gonna kind of do one. It's kind of interesting, but it will check out, I promise. So here's our bikini circles. I like translated. I like translated. So we are given that f of x is going to equal x minus 2 squared, x plus 2, and x minus 1, x squared minus 1, excuse me. And we want to find the zeros the multiplicities, if possible. And then the actions of the graph. And I'm referring to whether it bounces or crosses. Is that kind of what we're looking for in a minute? I hope. So first we want to find the zeros, and we want to make sure that it's factored out completely. Do we think it's factored out completely? Yes. Do we have an interest of squares in there at all? Do we have a pattern at all?
X minus 2 squared.
Okay, but we don't have to touch it. We're good. We can't go anything lower than that with that one. What about this one?
Squares?
Yep. Yep, it pops up. So x minus 2 squared, x plus 2, and then x plus 1, x minus 1. So then we can create a table whether of all the zeros that we have, and then we can also list whether the multiplicities and whether they go up or down or they bounce or cross on the graph. So we look at, okay, so we have the zeros, multiplicities, and the action. I'm gonna say action. So the zeros that we're going to get from this are going to be a couple. So if we take each of these instead of equal to 0, we're going to get a +2 for this, or yeah, +2 for that one. We're going to get a -2 on here, this one. We're going to get a -1 and a +1. And with the multiplicities, if they show up twice or they have a power, so we could say that the x minus 2, because it can be written like this, or it can be written x minus 2, x minus 2. Same thing, if you had 2 to the 3rd power, you're basically just taking 2 times 2 times 2 times 2, and you're repeating it. So with us having a multiplicity of 2, or having a power of 2, we would have a multiplicity of 2. And when we have an even multiplicity, where it shows up twice, are we bouncing or are we crossing? Yes. And then the rest of them only show up once, so we would have multiplicity of 1 for each. And are we crossing or bouncing? Crossing. So then with this type of equation, are we going to, what would be my highest power?
2.
Hmm.
Oh. Don't you add the powers?
What would be my highest degree? That.
Would it be 5?
Yeah. So if you factor this out, we're gonna get an x squared. If we FOIL it again, x cubed, x to the 4th, x to the 5th. You could factor it out, but that's gonna take you a little bit. It's gonna be a little bit. And then the end behaviors. What are we gonna be, a U-shaped or an S shape?
Oh, S.
S. Since we have the even power, or the odd, excuse me, odd power. And then as x goes to infinity, f of x will go to And then let's that's negative. In line. Negative infinity. And then as x goes to positive infinity, f of x will go to what? So we know if we're S-shaped, we're going to be something like this. Kind of. More squiggly in the middle, but yes. Yes. Sorry. I was trying to write it above. So as we go to the left, and then we're also going down, we're going to go into negative infinity with our y. And as we go right to the positive infinity, we're going to be going up into positive infinity with the y. If we had a negative on it, this graph would flip. So if negative, we would go something like this. So then we would have just the similar cases just flipped.
What would be negative, the degree?
Yes. Or if we would have, yeah. Or none of that, scratch that. If we had this part be negative. If the front was negative, because we were just basically rotating this.
What does the group tell you again? Tell you how many times there are?
Yes, that tells you, should tell you that, and then if you go the n-1,
It tells you how many intercepts.
correct, how many turning points that you should have. And then what was that one? Speaking of turning points, how many do we have? Yes. So degree -1 or n minus, let's say equals n-1. So when we graph it, we would know that one would go up, 2, 3, 4. Come to think. But we're going to be still ending up here and down here. And then if we wanted to find the x-intercepts, what would it be? What do you think it'd be? Huh? X-intercept or the, excuse me, y-intercept is what I meant.
It's a 0.
Yes. X minus 2, x plus 2, x plus 1, x minus 1. Okay. So then if we plug in a 0, 0 minus 2, 0 plus 2, 0 plus 1, and 0 minus 1. In the end, we should get a -8. So our ordered power would be 0, -8. Is that okay? Questions, comments, concerns? Tell me if anything, I promise. Good, just one page.
And our zeros would just be where if the graph. We would, if we wanted to finish the entire graph, it's just where we would put the line through or cross or bounce off.
That's where the x-intercepts would come in. So that's where the bounce and cross would go. So at those various points on the x-intercepts, that's where it's going to either go through it, or it's going to just like, or it's going to just bounce off it. And then good. page. And then I need to use the transformations. So something to note, so something with the functions that you're given, depending on the style that it is, if it's inside the function, it will shift the graph. I was talking about some of this both the other day. I believe it shifts the graphs on the X. Depending on like this X plus 3, X minus 3, it's gonna shift that many spaces. And if it's outside, that's where you're gonna get the y-intercepts type stuff from it. That's where it's gonna shift through it. I'm just gonna say 3 is the example. It's gonna go shift on y. And then if we have a value at the front of it, and we're more than 1, I believe, well, 1 or 2, I think it is, we're gonna stretch or compress that graph. Stretch. Stretch. I was like, I can't remember stretch or compress. And it's multiplied. We're going to stretch. And if we are less than 1, we're going to stretch the graph. Oh, wrong one. I'm close. Okay, so if we look at so if we look with x is equal to -2, x plus 1 squared cubed plus 2. And then a good order for them when you're doing the calculations, because I know there's a couple ways you can do them. You can either, because I know some instructors want you to point them out and then be like, oh, this is going to be a stretch, this is going to be a shift, this is going to be a shift of this. And then either take the key points of the given function that you're given, so such as like a parabola or logarithmics, because they all have key points. And you can take those values and plug them into them, or you can just look at the graph and just shift where you need to go. It's
If it's negative on the inside, like I thought it shifts on the y-axis. Well, at least that's what how I know my notes.
possible. Is it, do you think of it being flipped?
No, it should be that way. If it's on the inside, you do the opposite and it's like shifting left and right.
Yes.
It shifts on the y-axis. Like if it's negative on the inside.
Yes.
I'll
Yes.
link on the y-axis.
Yes.
Oh, the reflections.
Yes. Thank you. That
I said on the y.
on the y-axis. This part.
Yeah.
So a good safe order for it is to do the stretching compressions first.
Is that a 3 squared?
Yes. Where? 3 square right here?
Yeah.
Yes. And then reflections. And the shifts. So our original function would be what type? What type of function are we in? For the sake of time, I'm going to say that we are in x cubed.
Oh,
So, and then the transformations for it. I think. Would be a vertical stretch of 2. Yeah, by 2. Then and then we also have a vertical reflection. Due to the negative. And then we have a horizontal shift. Let's say HS. Left 1. And then a vertical shift up 2. Yeah, because it's opposite on the inside. So you can graph it original with the original function x cubed and then take the shifts and do it with it. That's doable, depending on which space that you have, or if you're given scratch paper. But so I'm gonna write the original function first. So f of x equaling x cubed, and the key points are 0, 0, 1, 1. And -1, -1. So this is where I was talking about, you can take these numbers and multiply it by, if you can remember where these are at, and plug them into these. So like multiplying this by 2, doing everything by negative for the y values, I believe. Yeah, y values, I think. And then adding or subtracting the -1 from the x's, and then adding 2 to the y's from that equation. So then the given function, which would be this part. Our function would be going through and using those values. So one of the points would be at 0, 0. Another one is at -1, 2. And -2, 4, which is way up there. And I threw that one kind of fast and jumpy, but
You should, just. Yeah.
so we could take these ones, and we would just take each of these and plug them in for the designated spot where they're at, and then include the negative with it, and then just go through this step all the way down, going through this order through each of the key points that were given. So like the library functions, for most of them have them, and then do those equations to it, and it should shift it to where it needs to be.
On the stretches, are you multiplying the x's or the y's on the points by 2, by -2?
I believe it's to the, I want to see the x's. I can tell you very quickly. The x's, yes. If it's horizontal, you're gonna go to the x's. If it's vertical, you're gonna do the y's. Say, stretch. You can see that. Vertical shift to the what I say, x's, yes, to the x's, and then horizontal shifts to the y's.
What about the stretches?
The same thing.
Oh,
They're gonna do the same thing, depending on whether they're a vertical or a horizontal shift.
so where's the positive x point on the, and that's what we on the right side of the graph, on like the quadrant 4.
Yes. Mhm.
Yeah. Where is it?
Oh, perfect. So, which one are you referring to really quick?
Because it's x cubed, right?
Yes.
So the endpoint should be 1 going to infinity for y, and then y going to -infinity, right?
Yes. So as it's going this way, it's gonna go this way, and as it's going that direction, it's gonna go down.
Yeah, so where's the point going down?
It would be a third. There would be a third point over here, or a fourth. So not sure how we could take where x equals 1. So go f1, 2, 1 plus 1 cubed plus 2. That'll give us another point. With negative of 1 would give us a -14, which would be pretty far ways down.
If we have to multiply the two by the y's or something, isn't that like a or something?
Yes. So that's where we would take the -2 and multiply it into our x's, I want to say, and then flip it. Because we're gonna rotate this direction.
Oh, so that happens when you flip it.
Once you multiply those values in.
Thank
Any others? Or do you want to cover long division really quick? Unless there's something else. Yes.
Um. I'll find the asymptotes of a rational function.
More of them installed together. So you want something with an oblique? Or no,
That's the,
that slanted one? No, okay. Just ask.
I have, it's just because I got it wrong on the test, so the only, I think you should test these X. It doesn't, I don't think it has the answers.
Okay, that's fine. We're looking at number 2.
Yeah.
So,
All of this graphs are possible answers.
so for this one, we have h of x is equal to -3 squared all over x squared minus 1. So we would want to factor it first, to get everything factored, just in the sense so that, as we were showing earlier, with the partial fraction decomposition, where they cross out, that would give us a whole. That's the hint of what, that's the purpose of that. So that's where we would just have a hole in the graph and we would just, like, if you were to take our pen, we would just jump over it. So like that. So we want to factor it first. So we would have -3 x squared over x plus 1, x minus 1. We can find our zeros, where our x cannot equal. So we cannot let x equal 1 or -1. So that portion would be where this point, so right on 1 would be where we can't equal. Let me just make sure I'm right on the other one. Is where, okay. And then with the horizontal asymptotes, it's the cases where we have the difference of powers. In this case, we have the same power, because we can have, do I need to list the cases for you? Would like them? No, maybe so, yes, okay. Making sure. So if we have something with a sub n, x to the m, using the m as my power, or that's m. And then a sub n, x to the m. So we're ultimately just looking at x of n and x of m. And if n is less than m, we will have a horizontal asymptote. Sorry, I'm abbreviating. At y equals 0. If n equals m, if n equals m, such as the case we're currently in, we would just take the coefficients. We're going to look at a x to the n, a x to the. And so it would just be a over b. And then if we're greater than, so n is greater than m, our horizontal asymptote there would be any. So for this one, we would have a -3 over a 1. So we'd be following this case right in the middle, since our 3x squared and our x squared. So this one, we would have a -3 over 1, and we would just have a -3 as our horizontal asymptote. This part, I think you can do a couple of ways. You could plug it into a table and plug in values and then just kind of go through it. And you should get some points that are in either in some of these points that you have.
Not lost me what happened there.
Say that again, which part?
Not lost me what happened
This part,
there.
right, you said?
You found out the.
After found this?
What x can equal. All that which you just wrote.
This part?
Yeah.
So for this part, we want to know where x cannot equal, which would give us a 0 in the denominator. And then after that, we want to know the asymptotes. So this would be my verticals. And then this would be my horizontals, horizontal asymptotes, like horizon. So we're looking at those, we have different cases. For like when we did where it can't equal, that's where we get these holes or where we can't touch it. So that's where the graph would get so close to it and not touch it at all. But it would be like 0.99999.
Oh, to get the
repeating.
horizon asymptote, you divided the leading term.
The bottom part to get this part. And then for this part, we look at just the cases for the horizontal asymptotes, whether they're greater than, less than, or equal to the powers that we
Those
have.
were just cases?
Yeah.
Okay.
Cases, rules, either or. How you want to word them? I was just trying to abbreviate pretty quick. And we could I would want to just plug it into a table, this equation, plug in values that aren't x equals 1 and -1, and it should give you points where they're at, and they'll give you the behaviors and everything for it too. Good. Okay. I know it is 9:16. If you guys have any questions, you can ask me really quick. And then the QR codes are there if you need them. And then if you guys have questions during the night or anything, you can also message me through Canvas on there. And I will reply back within 24 hours. That's my go-to. If you didn't sign in on the front, please do. Or if you want photos of this, you can come and I can slide the pages. What was the last one? Let's